Lesson 105. So we're going to continue on with the other two electrical terms that we did not cover in Lesson 104. That will be, of course, resistance and power. And then we're going to add one little piece to the end, and that's just a little bit of print reading here. We're going to talk about the prints that are included with your EWR book. All right, so first term, resistance. This is kind of the odd man out, the oddball. So we're going to measure this in ohms or represent it with the omega symbol, the ohm symbol, abbreviated by the letter R. So again, you're going to see it either as the omega symbol or the letter R. It's a measure of materials opposition to current flow. Okay, so this one doesn't really have much to do with the electrical flow or the electricity. It has to do with actually the conductor, right? So all materials resist current flow to some degree or another. Okay, copper wire still has a resistance. Aluminum wire certainly has a resistance. You know, some of the best conductors, gold, silver, do have some resistance. Nothing is a perfect conductor. Obviously, some things are almost perfect insulators, right? Meaning they have a very high resistance, and then are good conductors. We think of copper, we think of aluminum. Most metals have a low resistance, right? So what factors can determine the resistance of a material? So for any given conductor, you know, the first thing, I already talked about it 2 or 3 times here, is the conductor material. Okay, copper is a better conductor than aluminum. Gold and silver are even better than copper. All right, and actually, then we can think of you know, rubber has very high resistance. It's a terrible conductor, right? Something they mentioned in the book, it's not terribly important to us till we get to voltage drop, in my opinion, but it is this K value. So every material is assigned a K value or has a certain K value. For your purposes for now, I want you to know that for copper, the K value is 12.9 generally, and then aluminum is 21.2. You're going to see different problems and questions in the text, and sometimes they'll give you a K value. If they give you the value, go ahead and use that. And in fact, I think in all cases the text does give you a K value. But in a real world application, if you're dealing with copper, 12.9, aluminum, 21.2. When we do voltage drop calculations, we'll really get into that. We'll need to know that K value, but for now, just keep that in mind. What other factors? The cross-sectional area. So basically the size. How big is your wire or your conductor? The bigger the wire, the better the conductor, right? That's just a general rule. So, you know, again, I mentioned wire size, bigger wire, better conductor. Nice and easy. The length. The longer a material is, the more resistance it has. Because again, every material resists current flow to some degree or another. So you take that, you know, if it resists current flow and it's 1 foot, you make it 2 foot and it has even more resistance, and 3 foot and 200 foot and 500 foot and 1,000 foot obviously gets incrementally has more and more resistance the longer you go. And that's usually the main culprit when we talk about voltage drop. So long conductors can cause us to actually lose voltage because of resistance, right? Again, we'll talk about that and how to calculate that in great detail later on. And then our last factor here that we want to mention is actually going to be temperature. Okay, generally the hotter the environment is, the hotter the conductors are, the more resistance they have, right? So the more opposition to current flow they have. So as electricians, we generally like colder as opposed to hotter, right? All right, so power is sort of our last guy they want to hit on. Of course, we measure that in watts, abbreviated by W. As I said, or as the title implies here, power is going to be abbreviated by the letter P. So again, you'll see it as P or W. Get used to seeing it either way. But as we said, it's a measure of work. Watts or power is a measure of electrical work. And what is electrical work? I think, you know, we all have a general idea, but let's just go ahead and say it here. So work, when it comes to electricity, can be producing light, producing heat, or cooling. Motion, usually in terms of an electric motor. And then sound would be kind of your big ones. And I'm sure there's some others you can think of, but that's the main type of electrical work we are talking about. And of course, watts is made up of volts times amps mathematically. We'll talk more on that when we get into the sort of the Ohm's law chapters coming up here. And they give us this, I think, a really nice chart to sort of sum everything up. Okay, we have I is used to represent current. Current is measured in amps. A is used to represent amps. Okay, so if you see any of those values or letters, we're talking about ampacity, right? Same thing, E is used to represent voltage. Voltage is measured in volts, and V is used to represent volts. We have R for resistance, measured in ohms, and then the omega symbol. And then P is used to represent power, power is measured in watts, and W is used to represent watts. So again, take a mental snapshot of this guy right here. That's a very helpful chart. You can take a lot of information from there. So enough about our electrical terms. Let's briefly talk about print reading. Listen, this could be a class in itself here. I'm only going to spend a little bit of time talking about the prints that come with our textbooks. So our plans are found in the back of the EWR book. We have a set of plans folded up. Take a moment to unfold those. I will actually, on the LMS, post a link to download a PDF version of those as well, so you can view them on your computer. Every one of our EWR chapters that sort of references, we sort of have this house that we're working with. They're referencing what is shown on these plans. And the book does a nice job of taking the particular section of the plans and putting it in the book, so you don't necessarily always have to open up that set of plans for every chapter. One thing to mention, I don't think they do a great job making this known, but there is a specification book. Actually, it's not really a book, it's a couple sections of pages, but there's a specification section on page 725 of the EWR book. Several questions are going to ask you some specific things that are going to be found in the specifications. So please note that those are in that location, page 725. You will have to reference that from time to time, right? And then here, just going to take a quick look at every page here, again, briefly. And these plans are a little bit odd, to be quite honest. Generally in residential, there's not always an electrical set of plans. And if there is, it can run the gamut of what they look like. And this is just one example. Again, I find them to be just a little odd. But anyway, here we're looking at a foundation basement plan. Nothing electrical here yet. Here we get to the first floor plan. Once again, nothing electrical. This is just layout. You notice they give us some info about windows, doors, and the book talks about exactly what all this means. Some section indicators, right? Now we get on to this window and door schedule and this south elevation. Again, these things probably wouldn't be combined onto one page if this was a real job. We get some cabinet information on page 4 here. We get and then an east elevation. Here we have a plot plan, north elevation. Again, an odd mix of things. But now here we're actually getting into something a little more electrical. Notice we have a schedule of special purpose outlets. We have panel A and panel B schedules, and then for some reason they threw the west elevation on there. As I said, kind of odd, but listen, it's all good information. They presented it in an interesting way, but it's all there nonetheless. Okay, on to page 7 now. We have a cross section. Page 8, this is our first true electrical plan. They're showing us the basement here in particular. Notice we have a legend of electrical symbols. Take note of that. Here again, now we have the first floor electrical plan, page 9. Then we have a kind of a cross section of a swimming pool wiring. We have a chapter all about swimming pool wiring towards the end of the year, so we'll be referencing that at that point as well. Page this doesn't actually have a number, but what it is a blank page. Their intent is you could draw on that, your own electrical drawings, notes, diagrams, everything like that for the basement. Now here's one for the first floor. Again, like I said, I will post a link to download these in PDF form as well. But again, when the text references, the EWR text in particular references this house, the EWR plans, this is what they're talking about. They'll reproduce whatever area we're talking about in a chapter actually in the text as well, but know that it comes from these plans, right? And again, don't forget about that spec book, the spec section on page 725.